Hey folks, all right, as you know, I'm not here today. I want to go through this pretty quick example so you can start doing some work on your own, and you can always refer back to this as notes. As mentioned in class, this is something I found literally over 20 years ago. I have not used it, I just randomly thought about it and thought, oh, this is kind of fun. Anyhow, I will also put the website up if I can. This is just a preview. It's supposed to be kind of something funny. X and Y meet a beautiful dance that often leads to a great destruction. This be foreshadowing. That's a fake person. This is what we are doing today, or what we're continuing to do. So much of what you know is based on your own misconception. Now, these are really simple. We're going to go through these pretty quickly. Awesome animations there. I wish this whole thing was on there. There we go. Awesome animations there. This is Einstein. He gets hit in the head, and we're going to break down your misconceptions. Now, these misconceptions also come from cartoons. Now, there are things that people believe to be true, but they are 100% not. The third one you definitely should know is not true. But misconception number one, going fast horizontally means you won't fall at all. Essentially, people think if I go really fast, and there are two things at the same level, as I go as fast as possible and I don't jump, that I can make it from one side to the other because I'm going wicked fast like the Roadrunner. That is 100% untrue. As soon as they leave the cliff, they start to fall, and what you should know is that projectile motion fashion. Misconception number two is that if you go fast enough, you won't fall at all. That's kind of exactly like misconception number one, and again, totally not true, meaning as soon as you go off, it does not matter if you were going the speed of sound, if you were going 1,000,000 miles an hour, as soon as you leave that cliff, you start to fall down. It might be very small, but you're going to start to fall down. And then misconception number three is just silly, that gravity won't act on you unless you look down at all. I would act this out, but you know I got hurt this past week, so if I do that, I will likely fall down and hurt myself more. But essentially, if you just walked and stepped off something, but you looked up, you could walk and never fall down. Obviously, that's not true. You start to fall down right away. Gravity is I don't like that they use the word force here. We know gravity is an acceleration that is always acting on us. It's always going down. It does not matter what something is doing. If something's going sideways, it doesn't care. Gravity is just going down, pulling you down at a rate of 9.8 meters per second squared. Now, hopefully you can see this. There's a green car that went, and then there's a red car that went, and you can see that they all match up, that every time interval is supposed to be the same. So it does not matter that the green car fell straight down or that this car was traveling in that parabolic motion. Every time interval, they were the exact same spot because gravity does not care that it was moving. It is just pulling things straight down. This is some animation that we're going to skip. And now this is a classic question that we have talked about before. This animation is also an amazing animation that if you are holding a gun and you drop a bullet at the same time, you shoot and drop, which one will hit the ground first? We've discussed this at length. Hopefully you know that. Ooh, find that. Ready for the awesome animation? If I hit the light, maybe that'll be a little bit better. It's a little better. Okay. You can see again that every time interval, if I take a straight line, I take a straight line. And this, I can post I will post a Mythbusters episode where they do this. Even in air resistance, they will hit the ground at the same time. They're always lined up. As far as the acceleration of gravity is concerned, you are just pulling it down. If you were this little buddy sitting right on top of that bullet, and as it's traveling, you are holding on real tight, all you know is that you're falling straight down. You feel like you're not moving, just like if you're in a car. So, what these two things tell us is that for every projectile motion question, once something is thrown, I take something, I throw it across the room. Once something is thrown, the horizontal acceleration is always 0. The vertical acceleration is always 9.8 meters per second squared, straight down. Now, what that animation shows you is that if we ignore air resistance, which we will often do, if we ignore air resistance, that as this bird is flying, this bird was carrying an egg. And the bird dropped the egg trying to land right on this guy's head. And again, every moment in time, the egg is underneath the bird. It never slows down or speeds up horizontally. The bird is traveling the same speed, and they will always line up such that when the egg hits the guy in the head, the bird would be exactly over his head. So there's a classic physics question. For some reason, if you are in the back of a pickup truck and you shoot an arrow straight up in the air, where will you see the arrow come down? Will the arrow come down behind the truck, in front of the truck, or in the truck? And hopefully you know this is one of those trick questions, and the answer should be whoop, right in the truck, because you shot it perfectly straight up and down. So we all know what upscalators and downscalators are. Those are the things that people call escalators that go up and down. I just give a direction. There are the ones that also go sideways, typically at the airport. I don't know why people are so lazy at the airport, but you stand on that moving sidewalk at the airport. While you're moving, you happen to be holding this pen. Well, if I'm moving and the pen is moving, if I were to throw the pen up in the air, but I'm not actually walking, I'm just going at the same speed. If I were to throw the pen up in the air, I would just see the pen up in the air go up and down and up and down. Just like if you were in this truck, you would see the arrow go straight up and come straight down. But somebody else watching you on the moving sidewalk, like, oh, look, that is moving to the side. I don't know why they're watching you. It's a little weird, but that's what they're doing. And you would see all of that again. You don't throw the thing up and it doesn't come down behind you. That would not be understanding the laws of physics, and or you would never walk and play catch with yourself. Another animation that we're skipping, another animation that we're skipping, another animation that we're skipping. Actually, this is kind of cool. You see things that go horizontal. It's very slow. Again, this is over 20 years old. You see things that go vertical. Notice the distances get bigger and smaller. Well, now you'll see that with a projectile, all of those time frames are again identical. We do not care that things are going up and down or sideways. Time is a scalar quantity, so it goes with both. Now, I have given you methods to solve these problems. We've done this once. This is a different methodology, which is why I'm showing it to you. But the 4 steps that they recommend here, make a list of everything you know. Keep X and Y separate. We have done that. Make time the crossover variable, meaning time works in both the X and the Y direction. Use the column with only one unknown. So this is a little different. I tell you to list all your variables and find the I don't care variable. They're saying list the column with only one unknown and solve for time, because it doesn't matter what the problem is or what the question is. Time is the key. Time unlocks the door so you can do all of the physics. And then once you have time on the X or the Y side, you can use it for the other side. Now, here is their example. It's a little stunt alien. Woo, very exciting. He runs and lands in that little bucket of water. The question is, how far away does he land? Now, I would do this a little bit differently. I might set it up afterwards and do the same thing. I'm going to write down our given information so we can do it 2 times. My given information is he has a delta Y, I'm going to call it, of 50 meters. 50 meters down. And I know he is running horizontally. That is an initial velocity in the X direction of 5 meters per second. So I'm going to go through how they solve it here, and then I will solve it one time for you the way that I would do it. So you can see both methods. Now, they say make a list, keep X and Y separate. That's fine. We make our list. This website uses delta S for a distance. That's an older terminology. This is delta X, and they have negative 50 meters. So they are defining down as negative. We know if things are only going in one direction, we can define that as negative or positive. I am going to choose to do it positive later on. They know that my initial velocity in the X direction is 5 meters per second. Now, stuff that was unknown was this horizontal displacement. Again, they use delta S. We would use an X and a Y. Identify the hidden information. That's all the stuff that I need to know, but that's not given. That is stuff like the initial velocity in the Y direction. He was running this way. If there was no gravity, he would have kept going, never falling. So he started falling down at 0 meters per second. He falls down because of the downward acceleration of gravity, negative 9.8 meters per second squared. That matches their distance. Again, I will say that it's going to be positive because I will define down as positive. We know there's no acceleration in the x direction. And now, eventually, that means t is on both sides. Now, the reason why their method was solve for the side with one unknown is the way they set this up. We have two unknowns, delta x, or distance, and time. On this, we have one unknown, just time. My directions have always been list all the stuff and solve for the side where you know the most stuff. Again, I will go through that. So they just moved that over there. Now we use the column to solve for time. They're going to use the delta x equation as VIT plus 1/2 AT squared. They plug all our stuff in again. They have a negative and a negative, which means down is negative. You should know a negative divided by a negative, that's a later step, is a positive. So the number works. We do all the math. They get 3.2 seconds. Once I know 3.2 seconds over here, I can use it over here, plug it back in. Now they use this average velocity equation. I don't do that because this only works if acceleration is 0, which obviously it does here. I will show you my method. My head keeps getting cut off. I will show you my method as well so you can see both ways to do it. But they get you plug in the time of 3.2 seconds and you get a distance of 16 meters. That means this little guy falls off 16 meters away as he is running. That is exactly how they do it. Now I will run through my method. I've got all my equations up there. Again, I'm going to say my horizontal side and my vertical side. Then we have a initial velocity, a final velocity, an acceleration, a delta x, and a time. Then a time, a delta y, an acceleration, an initial velocity, and a final velocity. And I can, all right, everything is there. Perfect. Now I'm going to plug in all the stuff that I knew. They gave me an initial velocity of 5 meters per second horizontally. I wrote that down before. They told me he fell down 50 meters. I'll put my little arrow down. That was the given information. Hidden information. See if I can grab a different color if it shows up. Hidden information. Acceleration of gravity, 9.8 meters per second squared. Straight down. Hidden information, 0 meters per second squared in the x. Hidden information, it starts falling from rest. So that is all my stuff that I know now. I know because I know physics. If there's a 0 acceleration in the x direction, that means the initial and the final velocity are also the same. 5 meters per second. The key is the time. So I look and I say, hey, which side do I know more stuff? I know 3 different things over here. I know basically the same stuff over here, so I need to solve on this side. I don't care about VF, thus I know to pick my delta x or my displacement equation. It doesn't matter that it's x or y, it's the same equation. So I would say delta y equals VI times delta t plus 1/2 times a times delta t squared. My initial velocity is 0. That whole thing goes away. So I have delta y equals 1/2 a times delta t squared. We've done this a bunch of times before. I have down and down, so I don't care about the negatives. So I have 50 equals 1/2 times 9.8 times t squared. We rearrange that. That should be 2 times d divided by 9.8. That time comes out to 3.2 seconds. Once I plug that up here, 3.2 seconds, I know time is the same on both sides. So I say 3.2 seconds. Then I have a delta x. Now, I have a delta x in this equation, and my VF squared equation also has a delta x. But if that's 0 on the x side, I can't use it. I have to use this equation. Delta x equals VI times t plus 1/2 times a times t squared. Since acceleration is 0, that's why I use this equation, because it always works as opposed to the average velocity equation. Then I say delta x equals 3.2, sorry, 5 meters per second times 3.2 seconds. That is 16 meters. That's all I have. I'm hopeful that this was helpful for you. By all means, if there are any questions, drop me an email, and I will talk to you all later.